welcome back to Let's Do Mathematics. Today we have a problem of JEE Advanced 2022. We have given problem that let Z bar denote the complex conjugate of a complex number Z. If Z is a non-zero complex number for which both real and imaginary parts of Z bar square plus 1 over Z square are integers, then which of the following are possible values of modulus of Z? So let's start solving this problem. So we have given complex number is Z bar square plus 1 over Z square. So let's take it as W is equal to Z bar square plus 1 over Z square, and if Z is equal to R times e raised to power iota theta, that is in, we have to written here, we have written here Z in exponential form. So therefore conjugate of Z is Z bar is equal to R e raised to power negative of iota theta, and Z square is equal to R square e raised to power iota 2 theta, and similarly Z bar square is equal to R square times e raised to power minus iota 2 theta. Therefore W can be written as in exponential form as R square e raised to power minus iota 2 theta, and this is plus 1 over R square, and if we take reciprocal of e raised to power iota 2 theta, this is equal to e raised to power minus iota 2 theta, and therefore this is R square plus 1 over R square times e raised to power minus iota 2 theta, and therefore W is equal to R square plus 1 over R square times this is cos 2 theta minus iota sin 2 theta in the trigonometric form. Now write the real part of W is equals to R is equal to, say this is R is equal to R square plus 1 over R square cos 2 theta, and imaginary part of W is equals to I is equal to negative of R square plus 1 over R square sin 2 theta, and we have given that real and imaginary parts are integers. Therefore R square plus I square is equal to a integer, and an integer, and this is a positive integer because a square of a integer is a positive integer. Therefore this is a positive integer. So squaring R square, capital R square, we have R square plus 1 over R square whole square cos square 2 theta plus R square plus 1 over R square whole square sin square 2 theta, and this is equal to sin square 2 theta, and this is equal to k. Now we can write here R square plus 1 over R square raised to power 2, and this is cos square 2 theta plus sin square 2 theta is equal to k. So this by trigonometric identity we can the value of this term is 1. So this we have R square plus 1 over R square raised to power 2 is equal to k. Now expanding this, we have R raised to power 4 plus 1 over R raised to power 4 plus 2 is equal to k. Now we can write this as R raised to power 8 plus 1 plus 2 R raised to power 4 is equal to k times R raised to power 4. We can write this as R raised to power 4 plus 2 minus k R raised to power 8 plus 2 minus k R raised to power 4 plus 1 is equal to 0. Now if we take R raised to power 4 is equal to t, then this equation reduces to a quadratic equation, and this is equal to t square plus 2 minus k times t plus 1 is equal to 0. And t is equal to, if we find the solution of this quadratic, then this is equal to t is equal to negative of 2 minus k plus minus under root b square. So this is b square 2 minus k square minus 4 over this is 2, and this is 2 is equal to negative of k minus 2 plus minus under root, this is under root 2 minus k plus 2 into 2 minus k minus 2. So this over this is 2. Now we have given in the options that all the positive here all the positive terms. So therefore we take here only value of positive. So t is equal to k minus 2 plus under root 4 minus k. This is 4 minus k times negative of k. So this is negative of k over 2. So t is equal to k minus 2 plus under root k square minus 4k over 2. So, and we have taken t is equal to r raised to power 4. So, k minus 2 plus under root k square minus 4k over 2. And this implies r is equal to k minus 2 plus under root k square minus 4k over 2 raised to power 1 over 4. Now we have to compare all the given options. So we have to check option A. So for option A, for option A, for A, if we take k minus 2 is equal to 43, that is, this implies k minus 2 is equal to 43. So this implies k is equal to 55, and we have to check the quantity in the square root, under a square root. So k square minus 4k is equal to k times k minus 4. So this is 45 times 41, and this can be written as 9 times 5 times 41, and this is equal to 3 under root 205, and this is what given in the option A. So this is a correct choice. So option A is correct. Now, therefore, option A is correct. Now, so this is the required value of modulus of Z. Now, and also note that here R is equal to, so here if Z is equal to R iota theta, then I want to mention here mod of Z is equal to R. So this is a notable point. Now let's move on the option B. So for option B, we have given in denominator 4. So we made here, first of all, we make here the value of R in terms of in terms of denominator 4. So R is equal to k minus 2. If we multiply 2 here, and this is, therefore this is k square minus 4k over, this is 4, and this becomes 1 over 4. So we have now denominator is 4. So if we compare 2 times k minus 2, and given quantity is here 7. So this is equal to, so 7. So k minus 2 is equal to 7 over 2, and k is equal to 7 over 2 plus 2, that is 11 over 2, and this is not an integer, therefore positive integer, therefore option B is incorrect. Similarly, if we check option C, for option C, we have option C is equals to, here denominator is 4 and 9. So we check for the 9. So for option C, 2 into k minus 2 is equal to 9. So this implies that k minus 2 is equal to 9 over 2. So this implies that k is equal to 9 over 2 plus 2, that is 13 over 2, and 13 over 2 is not an positive integer, therefore option C, choice C, is also incorrect. Now for option D, we are going to check here. So first of all, in the denominator in option D, we have given 6. So we make the value of R so that the denominator becomes 6. So R is equal to, we have k minus 2 plus under root k square minus 4k over 2 and raised to power 1 over 4. If we multiply 3 in numerator and 3 in denominator, then denominator becomes 6. Therefore this is 6, and this is 3 times k minus 2 plus under root 3 times k square minus 4k. Now compare the option D with this quantity. So we have option D is 7. So here, so 3 times k minus 2 is equal to 7. So this implies that k minus 2 is equal to 7 over 3, and this implies that k is equal to 7 over 3 plus 2 is equal to 13 over 3, and this is not any positive integer, therefore option D is also incorrect. So only is also incorrect. So we have obtained only, we have checked that option A is a correct option. So thus we have solved the problem, and we have obtained here that option A is correct answer of the given problem. This was a very important problem. So I hope you have understood all the process of the solving this problem, and I hope you have liked this solution. So don't forget to like this video and share with your friends, and subscribe this channel and hit the bell icon. So I'll see you in the next video. Thanks for watching.